So a quick introduction about myself. I am a graduate from aerospace engineering department. Pursued my my master's degree, and I'm pursuing my PhD in airline management, airline operations. And my PhD is specialized in aviation management in the disruption time or times of sustainable disruption. I have an experience in the CAE analysis, CFD, finite element, all of this design aspects, and I contributed in some aircraft deals in my airline, EDTO for some time. I hope everyone can introduce himself or herself. So there is a chat pod. Please feel free to introduce yourself into the chat space so that like we can know each other and what do you do, like your name, your affiliation, and what do you do? Okay. Like, if you don't mind, I would like everybody to put themselves on mute, please, so that like we don't have a disruption. Let me try if I can. Yeah, I can mute. Perfect. So the session, I call it the session knowledge pyramid, is basically what are we learning today. We will be talking about the ecosystem of an airline and what we call the extended divergent time operation. Basically, it's a type of the airline operations that's very, very important for the airlines. We will talk about the economic business impact, and then we will go to a little bit deeper into the technical part, significant systems, the aircraft significant systems, and then the performance effect on the aircraft value. And eventually, we will be combining all of these things into understanding what will affect the aircraft value in the market. The agenda that we'll be tackling today, we'll be talking about aircraft system significance and performance, the ecosystem of the airlines, and the need factor definition, the need of a factor definition. Why do we need to discretize actually the factors affecting the airline operations, airline cost structure, the fleet asset management and planning. We'll talk about the flight safety and en route performance and its effect on the aircraft market value. Actually, we'll be having a very quick introduction about the ETOPS operations, or what we started to call in 2014 the EDTO operations, basically. And there is an ICAO document about that released in 2017. You may have it as a reference, and I can share all the references with you afterward. And then we will be talking about choosing the dependent market value parameter, basically. What will affect the market value of an aircraft? When you start to sell or lease back or sublease an aircraft, what will affect the value? The aircraft engine combination on the significant systems, we'll be talking about that, and aircraft performance and reliability continuation, and we'll be having a glance talk about the economic effect of the startup and bankrupted airlines. Okay, let's start with my story, basically. In 2014, AirIndia decided to sell 5 aircraft, Boeing 777-200LR. What happened is they got an appraisal for this aircraft with $86 million per aircraft, and the average aircraft age was 6 years. Eventually, they sold the aircraft to Etihad Airways in 2014 with an average value of $67 million per aircraft. This is a very big discrepancy here. We're talking about like close to $20 million per single aircraft with a total of $100 million. AirIndia, they lost through the process of the aircraft valuation. And this is why we are tackling this subject today. We are trying to understand why is this happening? Why there is a very big difference between the aircraft appraisal and the final actual value of the aircraft sale. Okay, there must be something in the middle. So we have 5 levels of appraisals for the aircraft. Like we have 5 steps to evaluate the aircraft value. Within these 5 steps, we tackle only one step, which we call the desktop appraisal. you value the aircraft based on your computer desktop. You're sitting down in front of your computer, you start to value the aircraft, and that's it, end of story. And actually, you will find this discrepancy, $20 million between the aircraft, the actual aircraft value, and the market appraised value. Okay, so some technicalities about the Boeing 777. We say that the Boeing 777, it got a Guinness record a few years ago with the installed GE engine, and right now it is one of the most required aircraft, and this aircraft is very frequently required right now to be converted to freighter aircraft. So what we say right now is, if Air India decided to sell the aircraft in 2022, they will certainly get a higher even value than even 86. This is what I'm talking about. So time is a factor, although the aircraft will be aging even more, okay? So we'll be tackling all of these problems today. Let's start with the ecosystem of an airline. The ecosystem of an airline consists of the operation policy. What is your strategic policy in the operation? Demand and forecasting, this is a part of the equation. The fleet asset planning, how you basically manage the request or the requests and the requirements of the operations through your network planning and the revenue management and fleet asset planning. Eventually, we will go to scheduling and integrated planning, and we need to comply with the CAA and the airport coexistence. Like the demand, like for example, like we saw 3 months ago, the discrepancy that happened between specifically Emirates Airways and the Airport Authority of London Heathrow. And the problem was the capacity demand, the capacity of the airport was not able to catch all the demand or all the frequency of passengers going from or through Emirates. It was not only with Emirates Airways, it was with Egypt Air, Emirates Airways, Qatar Airways, like most of the operations going to London Heathrow. So anyhow, this is a part of the ecosystem. So airport airline coexistence, this is a very, very important part for that. Let's just like tackle some statistics around this topic. We say that 96% of the airline global fleet was grounded in 2020 due to COVID. And we say that 7% raise of the passenger demand happened with All Nippon Airways in Japan a few years ago through a coexistence, airport-airline coexistence between one of the airports in Japan and All Nippon Airways in Japan. So these are some insights about successful and failure stories, and we will start our conversation from these statistics. We say that 41% of the fleet acquired by Pan Am Airways, which was a very, very big airline. It was a flag carrier in the 1970s for USA. And actually, in the 70s, they started to acquire 41% of their entire fleet to be Boeing 747, the jumbo aircraft. Okay? So that means that when it was bankrupted, this airline, the Pan Am Airways, it was bankrupted in the 80s due to the wrong decisions that they took with selecting the wrong fleet. And when they started to sell this fleet back, they couldn't afford, or they couldn't get a good market value for this aircraft. So the damage that happened to the airways, to the airlines, was caused by the selection of the wrong fleet. I'm not saying that the Boeing 747 is a bad aircraft. I'm saying that the timing of acquiring this aircraft was wrong. And this is what we say. The market value is always depending on the time. So eventually we go to one of the biggest also topics that we will be talking today, how to save fuel, how to improve the operations and save fuel. So fuel management. We say that there is a very, very good story about Southwest Airlines, and you can just like Google it. The statistics are all over the place. 45% of year-over-year net income was improved by Southwest Airlines due to what we call the fuel hedging. So they were putting fuel management strategies for the pilots, for the airline, for the operations, for the network, to be able to save fuel as much as they can. And they could increase their year-over-year income profit to be 45%. That's a huge number, okay? So let's move to the economic target. Your economic target in the airline is always productivity and profitability. And to achieve that, you need to go through certain milestones. You need to have a good business model to comply with the safety management. We need to follow the flag carrier and politics. Basically, if you are a flag carrier, if you are a low-cost carrier or any type of air carrier, you have your own policies also. And then eventually the reputation. All of this will affect the productivity and profitability of the airline. But there is a very important question here, okay? Now we talked about the economic, but what's happening with the economic stability? Economic stability, which means that if I have a disruption, like the COVID, like the Great Recession in 2008, like the fuel recession in the 2015, like so many different, like 9/11, like so many different events that happened worldwide and were affecting the stability of the airline economy. Now, this is what we will be talking today about. We will be talking about not about the economic impact, because we had already a previous session about the economic impact. We will be talking about the economic stability. That's a very different story, okay? So the aircraft market value, how the aircraft market value will be affected through the aircraft systems and the design performance. So let's just like have a very quick glance about the economic implications. We say always that cost structure for any airline is depending on 30% fuel and oil, 9.5% maintenance cost, 11% crew salaries, and 27% aircraft ownership, insurance, and depreciation. So we're saying that the value of the aircraft contributes up to 27% of the airline economic value. This is a huge number, okay? We're talking almost about like quarter of the entire cost structure going to the depreciation of the aircraft. And this is why I want to emphasize today how this will affect, or how dealing with the aircraft systems and performance will affect actually the aircraft value. Okay, moving to the objective cost. We have two main categories of the cost. We have what we call objective cost, and we have what we call functional cost. Okay, talking about the objective cost, we say that the objective cost is discretized into the material purchase, fuel, oil, food, whatever else, salaries and workforce, services, ground and flight services, overflight services, ATC services, landing airports, and all that, and ownership and depreciation of the aircraft. These are the four main categories of the cost. Today we'll be concentrating on the ownership and depreciation. So one very important factor that people in the airlines need to understand is the difference between the direct cost and the indirect cost. Okay? The direct cost is what you pay for your flight to be performed. So the salary, the fuel, the fuel cost, the maintenance cost, the oil, like whatever you are spending on your current flight, this is direct cost. And this is only 48% of the entire airline economy. Imagine that. We're talking, of course, about the passenger aircraft, okay? For the cargo aircraft, you have other numbers, like the number is there, you can see it. But anyhow, this is not our performance today. Like our performance today, we'll be talking about that passenger economics. Okay, so the passenger aircraft economics, we are talking about 48% coming from the direct, whereas 52% is coming from the indirect cost. Okay, we're saying that the indirect cost has some contributions from the amortization of the aircraft, like how your debt is performing. Okay, like are you getting into an operation lease? You're subleasing the aircraft. You're leasing back the aircraft. You're having debts, like the amortization in general around the aircraft sales. Depreciation expenses related to the maintenance equipment, and again, depreciation expenses related to the ground and the operation equipment. So anyhow, we're saying with so other many factors, like this is coming from what we call the Department of Transportation Form 41. It's a part of the ICAO statistics. Okay, this is something called the BTS, like Bureau of Transportation Statistics, and they provide the airlines with all of these statistics. So we're saying that the precision of the aircraft contributes in 52% of the global airline economics, coming from the indirect costs. Okay, yeah, this is a very huge percentage, by the way. So fuel percentage is still important, but the indirect costs, you need to put it into consideration. And now we say that the total operating cost is coming from the ground operations and the flight operations. Let's just like have a glance about some examples of the ground factors, for example, that affect the airline economics or the direct operating cost. When you do a taxi, shall you go to the cut towards the nearest taxiway, or you just like use the braking efficiency and the thrust reversal, or you even go for a farther taxiway and you get out from a farther taxiway and save the brakes and thrust reversal? Like, this is a very big debate between the airlines, by the way. There is no accurate answer for that. Like, with every airline, they can have information bulletins towards that. Okay, so using the auxiliary power unit and consume more fuel, or depend on the ground equipment. Taxi with a single engine taxi, or moving and just save the wheel and anti-skid and auto brake and all of this stuff. Fuel servicing, shall I do tankering, or shall I just like go back and forth each trip with its fuel? It's a very, very complicated equation, this one. Okay, the water servicing, the same situation. It will add weight on the aircraft. So how can I deal with it? These are some examples, just a very quick glance about some ground factors that the pilot and the ground staff, they perform based on the airline policy and based on the network of the airline operations. Okay, so moving to the flight factors, we will find that we have other flight factors. Also, again, the people for flight operations, the dispatchers, the people working in the network planning, the pilots, they always consider. Like, for example, the load factor. The load factor is the amount of passenger or seats occupied by the passengers into relationship of the available seats offered by the airline. So this is a very important factor affecting basically the airline economy. Also, the performance measures, or what we call the performance value of the aircraft. It's basically the performance factor. Okay, like, it's actually when you see it in the flight plan, if you are a pilot listening here or someone working in the flight operation, if you take a look at the flight plan, you will find that there is something called cost index, and there is something called performance factor. The performance factor is calculated based on the age of the aircraft and the dry operating weight of the aircraft and so many other factors, how many cycles, how many hours, like the deactivated systems on the aircraft, like the extras on the aircraft, like a lot of factors. Eventually, the people in the research department in the flight operations, they come up with what we call performance factor, and we put it for the fuel management. We have something also called cost index. So basically, the cost index is the cost of time over the cost of fuel. So basically, whenever I am flying and the cost of fuel is very high, it is better for me to fly with lower speeds, okay, because I will consume less fuel, but the length of the flight will be extended. Okay, so this is the cost index. So basically, the higher cost index you get, what happens to the aircraft speed? Please put it in the chat. I know that there are a lot of people that will be aware about this answer, but in general, I need to know if you have higher cost index, what will happen in the aircraft speed? If you don't mind, 1 second, please, because like the laptop is getting out of charge, so I need to connect it. 1 second. I'm sorry for that. Yeah. So basically, hopefully it doesn't disconnect until I connect it. 1 second, please. Yeah, I think now it works. Okay, thank you. So, so basically, the cost index, whenever you increase the cost index value and you put it in your flight management system, the aircraft speed will be certainly increasing, because that means that the cost of time is higher than the cost of fuel. So, which means that I need to reach my destination in a shorter time, and I need to increase the speed of the aircraft. This is what happens basically, okay? So higher cost index, higher speed of the aircraft. We have the last part of the cost structure. We say the obligatory additives of the cost structure. We say here the airways, the NOTAM, the airworthiness directive, and the technical service policies. All of these factors are affecting the cost of the aircraft. So basically, or the cost of operation basically. So whenever you are flying from one destination, one city to the other, one spoke to the other, like you need to consider what the ATC is telling you and what the ICAO is, and the NOTAMs and like all the things that you are obligated to follow basically. Okay, we talk every session about this, the performance measures. We have certain economic performance measures that we need to follow. The ASK, the available seat kilometers, the capacity basically offered by the airline, the load factor, the occupation of the passengers, passenger spill, how many passengers are beyond the capacity, the ground times, aircraft resource utilization, GDP of the airline, of the country, and the revenue per passenger kilometer. So now let's get into the interesting part, how to value the aircraft. We have two methodologies to value the aircraft. The first one is people who love the finance, okay? So we have the financial people, they have certain methodology, and we have the technical people, they have extra methodologies. So the financial people, they consider the aircraft life, they tell you like, oh, this aircraft is valued based on the half-lifetime value of the aircraft. So if the aircraft span can work over like 30 years, we consider only 15 years, and then we give you the market value of the aircraft based on the half-lifetime value of the aircraft. Or let's say it needs to perform 40,000 cycles. So after 20,000 cycles, I tell you what is the value of the aircraft. This is coming from the financial people. I love this very, very much, okay? Also, another factor the financial people, they take into consideration how many times the aircraft was re-registered. Like I moved the aircraft from the registration of the Egyptian authority to, let's say, the Algerian authority to the Irish authority, whatever it takes. Okay, so this will take the value of the aircraft a little bit down. The active supply chain, that supply and demand, as we said, like nowadays we have a lot of demand for specific types, aircraft types, to be converted to freighter aircraft instead of passenger aircraft. So, and also the routine maintenance records, like what happens in the NPD maintenance planning document, what happens in the maintenance records, amount of repairs that happen, like all of this stuff. So basically, the people of the finance, bankers, appraisers, like all of the people that think economics and finance only, they consider these factors. But we are engineers, we are people, we are technical people, we are flight operation people, we are pilots. So we are technical people. So we understand that there are other factors that affect the aircraft value. And these factors are not very straightforward. Like, for example, what are the extras on this aircraft? Is this aircraft equipped by the ADS Bravo or ADS Charlie, ATSO system, a card system? Is it certified ETOPS or EDTO? Like, what are the types of certifications and approvals and extras on this aircraft? Also, the aircraft performance. How many derated takeoff I have on the aircraft? Like some of the aircraft, like they have like only one derated takeoff, and some other aircraft they have takeoff 0, takeoff 1, takeoff 2, takeoff 3, and they have like 3, 4 derated takeoffs. So then, like if you don't understand what is derated takeoff, is basically like some techniques that we trick the aircraft with some techniques to tell the aircraft that you need to consume less fuel because the weight, for example, is less, or I don't have enough passengers, or like something related to the airport runway, or like some other stuff. Like we will be talking about this a little bit later. incidents reports, how many in-flight shutdown you got, how many excessive G loads and vertical speeds you landed the aircraft with. So all of these factors are related to pilots, are related to flight operations, and also the operation conditions, like how I consider this aircraft operation. Like, is it flying to harsh conditions? Is it flying to areas where there are a lot of mountains, harsh conditions, very hot environment? Like, so all of this affects the value actually of and the depreciation of the aircraft. These are technical factors. This need to be added to the aircraft value for us to get a nice, decent, very close value of the real market value. Okay, so let's just have a very quick tackling for the financial valuation. Some considerations: we consider the propulsion system of the aircraft and the airplane type, basically. So both of them, they need to comply with Annex 6 and Annex 8. Annexes and Annex 8 is the airline operations and the airworthiness of the aircraft. So basically, we have so many annexes talking about how I shall consider the technical factors and convert them into financial factors. Okay, so each aircraft has a combination between airplane engine combination, and this affects actually the value of aircraft. Like, let's say, for example, like Airbus 320, it can be equipped by Pratt & Whitney engine, or IAE engine, or CFM engine, or like LEAP engine. So we have so many other selections of the engine options to be installed on the same aircraft. So with each airplane engine combination, we value the aircraft and we consider the performance factors of the aircraft. Okay, this is very, very interesting. This is some statistics that I did between the startup airlines and the bankrupted airlines. And I need you to pay attention to what's happening here in 2017. You will find that the gap between the starting airlines and the bankrupted airlines is big. So the number of aircraft that were added to the market were a little bit higher than what it should be. Okay, and then this gap started to go down again in 2018. Okay, so let's just try to figure out what happened from the IATA statistics in 2017 and 2018. Just remember that 2017, the gap between the bankrupted airlines, the loss of business airlines, and the startup airlines, the number of airlines that were starting the business is big. Okay, so I am expecting more aircraft in the market, more capacity, more operations. And in 2018, this gap started to go down again. Okay, let's see what happened. Oh, interesting. Look, 2017, the net profit for airlines, this is global, huh? The net profit for airlines was like changed like year over year, was around like $37.6 billion. It dropped. You see the statistics, some of them are in negative in 2018, okay? So it dropped to 27.3, and this drop comes from the difference of the capacity offered. So whenever I have a little bit of more demand for the aircraft value increases, and the airlines start to get their aircraft with higher value, and their profits go down. This is what happens, basically. This is the effect of the airline or aircraft value between 2017 and 2018. You see, so it's all supply chain, it's all supply and demand. And this is why, if you want to sell your aircraft with a higher value, you need to have information bulletins for your pilot, for your flight operations, about some procedures to follow in the flight operations. Okay, yeah. This is also interesting. This is a regression model curve for. I'm just like masking, of course, the numbers, because this is not yet published. So I need to mask it until I publish it. But anyhow, so you see that the quadratic curve here has a peak towards 2008. So there was a very big changeover point in the industry in 2008, in what we call the Great Recession. Okay, it didn't happen only in US, it affected the entire world. Okay, so this is just an insight about how to analyze the performance of the airlines globally. Okay, let's also take a look at this. This is the forecasting for the startup airlines. I am forecasting the startup airlines for the next 3 years to be almost the same as 2021. We will see if I am right or correct. Let's see. I use some forecasting techniques here, so let's see if I was right. We will know next year, inshallah. So anyhow, this is another example for the desktop appraisal, how the airlines, they value their aircraft. Okay, this is one aircraft, and this is the real appraised market value. Regardless that, again, I am asking the numbers, okay, but I want you to see this factor. You see here, the aircraft value is going down with a factor of 1.6 multiplied by the age of the aircraft. So each year, the aircraft is losing 1.6 multiplied by the age of its value. You know, so 1.6 million per year. So every year, the aircraft is losing its value, okay? So this is one aircraft. Take a look at the second aircraft. This is another example. Oh, this is a better aircraft. It is losing only 1.2 million of the market value each year. So aircraft number 2 is better than the aircraft number 1. I will not tell you, of course, what are the differences between this aircraft. And you see, like, just for you to know that this is a very good model. Look at the R-squared. Like, of course, people of economics and statistics will understand what is that. And so it's a very, very high statistical value. Like these results are very, very close, depending on the statistics of the market value. So this aircraft is losing only 1.2, whereas the first aircraft is losing 1.6 of its market value. Why is this happening? I can guarantee, I assure you that this is happening due to the differences of the performance measures of the technical performance measures, how this aircraft can perform in terms of the aircraft systems and aircraft performance in the market. You see, so I will talk about the technical factors, but before that, let's just like take a very, very quick glance about the regulations. We have Annex 6 talking about the aircraft operations, and we have Annex 8 talking about the aircraft airworthiness. And remember when I told you the aircraft, whenever it is re-registered from one authority to the other, it starts to lose its value. This is just a glance about the types of registrations. We have the state of design, state of manufacturing, state of operator, and state of registry. So whenever the state of registry changes between one operator to the other, the aircraft value goes down. And actually, I didn't say that. The people of economics are the ones who said that. Also, we have Chicago Convention in 1944, Article 83. So it says that the transfer of liability can be transferred from one authority to another authority. So basically, the state of registration. So that means that if I am taking my own liability in my own authority and I sold the aircraft to another authority, I can transfer this liability to the other authority, and they take it and they start to put more restrictions on the aircraft operation. So the aircraft value actually goes down due to this transfer of the liability. So basically, whenever you have an accident, you start to tell the other person, like, oh, it is your fault. Oh, no, it is your fault. Oh, you didn't tell me. So basically, this transfer, this is what drops down the market value. Let's go to the interesting part that everybody's waiting for, the technical valuation, okay? So the aircraft system dependence. So basically what we say here is that we have two things related to the aircraft system. We have the maintenance actions and the crew actions. So each aircraft has certain policies about how to deal with the maintenance planning document, how to deal with an aircraft within the limitations, how the operator is basically guiding you towards handling specific maintenance tasks. And in the operation part, we're talking about the information bulletins, we're talking about the operation procedures, the QRH, the FCOM, like all of the procedures related to the aircraft system. Until now, nothing is different, and you cannot improve anything. But this is actually a standard for each aircraft. So as I told you, two aircraft with two different systems from the manufacturer, one can have a higher value than the other. Remember, 1.6 versus 1.2. Just remember that. Okay. So also we say here that the aircraft, this is just an example about like one of the aircraft, a difference between the Airbus 320 and the Airbus 340. One has like 4 systems and the other one has 2 systems. So basically here we say that the 4-engine aircraft is more reliable than 2-engine aircraft. That is a fact, and I will show you specific statistics about that from the ICAO. So basically, this also affects the reliability of the aircraft and the value of the aircraft. The failure framework for the engine. Whenever you start to lose an engine, we have a hydraulic failure. This is affected by the engine failure. We have electrical failure. We have pneumatic failure, and so many other systems get affected. Even the aircraft performance get affected by the engine failure. Okay, so this is very interesting statistics. And here we talk about the difference between people in the flight school, okay, and the people working in commercial airlines. People in flight schools, they usually work with small aircraft, with piston engine, reciprocating engine aircraft, or even turboprop, like the best that they can get. But actually, for commercial aircraft, we have a different story. So let's start with the piston aircraft. So piston engine aircraft. So these statistics, they show that whenever I have one engine that brings a power of 1,000 horsepower, and I have another engine bringing 3,000 horsepower, what is happening in the failure rate of the engine? We find by the statistics coming from the ICAO, okay, that if you multiply the horsepower by 3, you get 7 times more the failure rate. So the more power you get for your engine, the more failure rate you get. That's a standard fact, okay? But this happens for the small piston reciprocating engine aircraft, okay? So people in the flight school, they can expect this result. They know eventually that whenever you increase the horsepower or you have a stronger engine, you are subjected to more failure rates, okay? And also, if I decide to put 2 engines on the aircraft versus 4 engines of the aircraft, let's say 4 engines of the aircraft with a total of 6,000 horsepower and 2 engines with a failure rate, with a total horsepower of like 6,000 horsepower. So here in this red highlighted point, we have 6,000 horsepower, and here we have also 6,000 horsepower. But the failure rate, as we said, for the smaller engine is less. This is why the total failure rate of the 4 engines is better than the failure rate of the 2 engines. And this is why all the aircraft worldwide, typically, unless like some exceptions, most of the aircraft worldwide, they have the kingdom or presidency aircraft. It has to be equipped by 4 engines because the failure rate is less than 2 engines aircraft. This is why we did that, okay? So basically we say here that the more engines you get, the better failure rate you get per total number of engines installed. Again, per total number per engine installed, okay? And this is why we say that the performance measures that the manufacturer put, they consider the performance measures based on 1 engine failure for a twin engine aircraft and 4 engines or 0 engine failure for a 4 engine aircraft. So the measures that the manufacturer is giving to you as an operator is different between the 2 engine aircraft and the 4 engine aircraft. That's very, very important point to consider, okay? Let's move to the current engine selection. We have like the very famous B2500. We have the CF6 Airbus 330. We have the PW4000. We have the Trent 700 Airbus 330 again. So you see here that ideally, whenever you increase the power of the engine, the failure rate goes down. But this is for turbo high bypass turbofan engine, and this is for single engine So that is a little bit different than the piston engines. This is why we say that the people in the flight school, they are subjected to different mathematics. They take the basics, but they are subjected to different methodology of operating the aircraft and maintaining it and working with the aircraft, other than the people working in commercial big airlines. Okay, so the difference is humongous. As you can see here, the failure rate is going down with higher power installed. I didn't say that the ECAO is the one who said that. Again, we're comparing here single engine. We didn't compare the total number of engines. We're comparing single engine failure. Okay, yeah. So the impact on aviation safety, we say that 46% of the failures coming from the human. So whenever I have any discrepancy on board on the aircraft, the pilot takes a wrong decision, or the maintenance personnel, they didn't take the right or the correct procedures, and this led to the aircraft to fall down. We have 10% engine failure rate, we have 8% equipment failure rate, we have 3% only maintenance error. Again, I didn't reveal these numbers. It is the ECAO. I just took these numbers from the ECAO and put them in a nice display. But actually, this is coming from the accidents reports from the ECAO. We say everything or every failure has a reason. So 46% of the failures in the industry are coming from the human error. Okay, this is very, very important for you to be aware that if you have an in-flight engine shutdown, if you have any discrepancy, VOR approach failure, you have, you go to the minimum, you're going with Cat 1, Cat 2, Cat 3 flight, like any type of any discrepancy that happens to you as a pilot or someone working with the flight operation, you need to be very aware that your contribution to the accident is 46%. And the other close to 50% are coming from anything else. ATC, equipment, engine, like anything else. And the maintenance error, 3% only, which is like, yeah, we're happy to hear that. So maintenance considerations, we consider something called configuration maintenance procedure, the ETO significant system list, and the supplemental maintenance programs. I will just go very quickly about the maintenance part. We say here that the supplemental maintenance programs, it is focusing on the verification program, centralized maintenance control, the NCC maintenance training procedure changes, the EDTO, the extended diversion time operations. So we have so many other considerations to consider here for the maintenance, but I will try to be a little bit towards the operation part, okay? So we have here the significant system. We have two types of significant systems. We have significant systems that are affecting the safety due to the failure or degradation in the system, or the system continuity, and they are related to the time scale. So let me just explain that. The significant systems on the aircraft, two aircraft significant system groups. We have group number one. They are the systems of the aircraft related to the engine failure. By ECAO regulation, by the annexes, by the ECAO documents, we call them group number one significant systems. And these are the ones that are affected by the engine failure. We have another group of the aircraft systems related to the time. Let me just give you some examples about that. For group one systems, we have the systems that are related to the fuel feed, the engines, electrical system, bleed, hydraulic, in-flight shutdown, anything related to the engine failure. Okay. Group number two, anything related to time, like the EDTO operation or ETOPS operation. We have the cargo fire suppression system, the fire extinguishing system for the fire. We have the oxygen capacity system on board. All of these are time limited. If you have an engine failure or depressurization system, okay, failure, or you have anything related to the flight performance, and you need just to do a drift down, you need to go down, to dive down. Let's not say dive because this is a very severe word. Okay, let's say we need to go down the altitude to the safe altitude, let's say of 10,000 feet. Okay, just the system related to this drift down time, this is called group 2 systems, and these are the systems affecting everything related to time in the aircraft. So whenever I am going back to the value of the aircraft, whenever we are considering the value of aircraft, we are considering static parameters, and we are considering time-related parameters related to group 2 systems. Okay, so just pay attention to that. The aircraft value is always dependent on the time. Okay, these are certain systems or significant systems on board on the aircraft: communication systems, APU, fire suppression system, propulsion, cargo fire, electrical systems, engine systems. Like in the next step, inshallah, like whenever we finish this this session, and I will introduce the next step, we will be talking in details about every single system of these systems. Okay, so this will be the focus of our next stage after we finish this event, inshallah. Okay, so just very quick demonstration on the EDTO. What is the ETOPS? The ETOPS basically was extended range operations by twin engines, and that was certified since 1950s. In 2012, the ICAO introduced in Annex 6 what we called EDTO, extended diversion time operation. And they started to say that any aircraft installed by two engines, installed with 2 engines or 4 engines or 3 engines, can fly for extended range. And this will require a little bit of extended fuel, and it will increase the flight hours of the aircraft. But at the same time, it will a little bit depreciate the aircraft faster. So you get more money, you can perform better flights, but you get less value, little bit of less value for your aircraft. So moving to the history of EDTO, it started in, like as I said, like the commercial flights started in 1950s after the Chicago Convention 1944, and then I mean the first step towards safety, okay, flight safety. And then in 1985, ICAO started to introduce the ETOPS operations. All the way until 2012, they started to introduce the EDTO operations. Okay. Also, one of the greatest mystery in worldwide is one of the systems that we are obligating to install it as an EDTO equipment right now is the ADS Charlie. People working in communication and ATS and flight operations, they know what is the ADS Charlie. It's basically one of the antennas that needs to be installed on the aircraft to send to the ground stations and the satellite the location, the continuous location of the aircraft. Okay, so this is something that started to be a significant system. This is what I'm telling you. I need some significant system for each type of operation. Okay. Okay. So now we have a very, very quick, I don't want to call it test or quiz, but like, yeah, like whoever knows the answer can just put it in the chat. Is the oxygen system capacity considered a significant EDTO item? Yes or no? Please let me know. If you know the answer, the oxygen capacity for passengers and for the cockpit crew. Okay. And the second question is, which one has less probability of component failure and better reliability? 2-engine equipped aircraft or 4-engine equipped aircraft? Also, please let me know your answers in the chat. Okay, now we move to the last part, the flight performance, range and distance. We say that we have 2 types of distances on board. On the aircraft, we have the specific range of ground specific range and air specific range. The specific range is basically the aircraft speed based on the fuel consumption. So whenever we consume more fuel, what is the expected aircraft speed? Either if I am crossing the distance on the ground or in flight. Okay, so I need to specify, this is why we call it the specific range. Okay, so the distance in general measured for all of the performance measures of the aircraft are distance on the ground. Okay, so this is just an example. Between Cairo and Mexico, we are crossing around like 6,000.6 nautical miles, and between Cairo and Argentina, 6.3 nautical miles. Although on map, it looks like Argentina is longer, but actually Mexico is longer. And we say that because actually the way the account started to change the way they measure the distances. It started in 1975, and they started to do amendments in ICAO Annex number 15 in 1975. Okay, so they started to introduce what we call Vincenty distance, or what we call the great cycle distance. Is basically the shortest path between 2 points, but this is on ground. So if I want to measure this distance in air, I have something else that needs to be considering the ground speed of the aircraft, or basically, am I flying headwind or tailwind, basically. So the distance in air is different than the distance on the ground, okay? This is why we have something called specific range in air and specific range on the ground, okay? Again, the flight stage is basically the length in time and distance of the aircraft utilization. So whenever I have longer flight stage, that means that I am moving for a longer flight. Is basically instead of 10 hours, 12 hours. This is a flight stage, basically, the time that I will be crossing in my flight. And certainly, it is depending on the significant systems and the ETOPS or EDTO approval. Just for us to introduce that, or like to talk about that, we have the like you see here, like 2 aircraft. Okay, the first class is for an aircraft that is not approved by EDTO. It has to go through a circle of 30 minutes. Okay, so this circle needs to be, the aircraft needs to follow the green path of the green path of the flight. Whereas if I have an approval for EDTO, I can just like go with directly between point A and point B. So shorter distance and better utilization for the aircraft. This is why, yeah, aircraft approved by EDTO, approved by extended range, will have a better value, better market value than the aircraft that is not approved by EDTO. Eventually, I am referring all what I'm saying to the market value of the aircraft. Okay, so whenever you have an EDTO approval, you go or you pass between 2 points with shorter path. So basically, the flight span is less, and utilization of the aircraft is less. Depreciation is less. Higher market value. Welcome on board. So this is why we take this into consideration in the comparison between 2 aircraft market value. And eventually the flight performance. Here, we introduce the flight hours. So basically, the flight hours on board is basically the hours that you pass. We have the airborne hours is from this point, if you see my cursor, from this point to that point until the touchdown, from the left off to the touchdown, we call it the airborne hours. And we have the block hours. The block hours, since you start to move with the aircraft until you go to your gate. We say this is shocks off, shocks on distance. Shocks off, shocks on. Whenever you start to take the shocks off of the wheel until the shocks on back to the wheel. And here I have the takeoff segment. I start my takeoff at this point. I have a question here. Do you think the takeoff starts from here or from here? From that point where I am pointing now, or from the left off? Just let me know in the chat and I will read all your answers later on. But actually the takeoff starts from here, okay? The takeoff starts from here, it starts from the lineup, starts from whenever you start to increase the engine throttle to the maximum power. This point is called left off. It's it's not called takeoff, it's called left up. And this is why the trip fuel on board starts to be calculated from here, from this point. This is trip up, the trip fuel. Before that is not called trip fuel, it's called taxi fuel. So taxi fuel plus trip fuel equals the block fuel on board. Okay, yeah. So, and this takes us to the 4 segments of the takeoff. Now we're just like 2-3 minutes away of finishing this session. We started like around like 6-7 minutes late, so I still have like 5 minutes. Okay, I will finish in 5 minutes, inshallah. So anyhow, these are the segments of the flight. We have 4 takeoff segments. First segment is basically you start to take a little bit of lift off until you start the second segment. You need to take a gradient for twin engine operation 2.4, and then you arrive to the acceleration segment number 3, and then you arrive to something called green dot speed is the 4th segment, and then you continue your climb beyond the 1500 feet. So these are the 4 segments of the aircraft takeoff. You see, the 4 segments starts from the takeoff distance. It's here. You see, starts from a specific point where you start to take off with the aircraft. All of this is called the takeoff segments. Okay. So after the lift off, I start to count the 4 segments, but all of this is the takeoff flight path of the aircraft. Okay. So if I want to improve this aircraft profile, if I want to improve it, first of all, I need to understand what is the green dot speed. Please let me know. Anyone from any pilot, anyone from flight operations, to hear me. Okay, I need you to tell me what is the green dot speed. You will find it on your screen. You will find it on the PFD. Okay, just let me know what is the green dot speed. Please put it in the chat. I will read all of this afterwards. Okay, here we are. The green dot speed is the maximum leftover drag point. So this is a little bit very technical, so the engineers would understand this in a better pace, but the lift over drag point, this is the green dot speed of the aircraft. And it increases with the CL until this point, and then it decreases again with the CL. So whenever you increase the lift coefficient of the airfoil or on the aircraft on board, you start to get less lift over drag. Okay, how this will happen? This is just, I'm leaving this part to the end because it's a little bit very technical. So we have certain points on the airfoil. Consider that this is the airfoil, okay? This is the wing, okay? And this is the CG, the aerodynamic center, and we have like so many other like references on board, okay, on the wing. So I want to tell you something. If I move the CG forward or aft, is this better for the aircraft or bad for the aircraft? What do you think? Again, if I move the CG, my point is, if I am loading the aircraft and I start to load the forward cargo more than the aft cargo, moving the CG more forward, is this better for the aircraft or worse for the aircraft? Please let me know in the comments again, and I will check all of these answers after we finish. Okay, so we have here an example of 2 aircraft, airplane 1 and airplane 2. Airplane 1 has a negative impact on the moment coefficient with angle of attack, and airplane 2 has a positive impact of the moment coefficient with the angle of attack. Which aircraft is more stable? Yeah, does anyone know? Yeah, please let me know again in the comments. I am really excited to read all of your comments in the chat. But let me tell you that airplane 1 is more stable than airplane 2. Okay, I will tell you why. That means that whenever I have a CM alpha or a change in the moment coefficient with the angle of attack going to the negative direction, that means a better stable aircraft. And this is very much appearing here. I have airplane 1 and airplane 2. Both of them, they are having negative impact. But airplane 2 is more stable than airplane 1. Okay, it has more cm up, it has more impact of the moment coefficient towards the negative part with increasing the angle of attack. This is advanced aerodynamics. Okay, guys, this is that the people working in the flight operations will relate very much. Okay, and also the people in the flight school, they will relate very much. Okay, so whenever I increase the moment coefficient towards the negative part with the angle of attack, that means better stability for the aircraft. But before we move here, but that means that whenever I move the CG of the aircraft forward, the CG, I move it forward, okay, the aircraft stability will be better. But that doesn't mean that the fuel consumption will be better. The aircraft stability will be better, but the fuel consumption will not be better. So let me just tell you the opposite. If I move the aircraft, if I move the CG, again, this is the last part that we will be talking about, so I'm leaving it to the end, okay? If I'm moving the CG towards the forward, okay, this is better stable aircraft. CG forward, this is better aircraft stability. If I'm moving the CG to the alternate forward means that the aircraft will be less stable, but more CG aft means higher angle of attack, means higher lift coefficient, means less lift over drag, means better performance and less V2 and V1 eventually V2 and V1, and higher gradient. Higher gradient. You need to go with higher angle on board. That is the equation. This is basically the trick. This is my recipe for you. You want to get better fuel consumption, move the CG aft, you get higher angle of attack. Okay, let me say here, CG aft, just to be able to continue and relate. CG aft, okay, alternate forward CG, alternate forward, which means aft. Higher angle of attack, higher CL, which means that I need less speeds. Less speeds, that means that I need less lift over drag, and then higher gradient to be able to overcome the obstacles. Less speeds, that means that I will consume less fuel. And this means that the aft CG will consume less fuel. And this will take us to what we call improved climb takeoff. I can extend the length of the runway, take higher speeds with so much less, or I can take with so much less speed, or I can take higher weights on the aircraft on board. So it's a benefit, but with less stability. You don't take anything in life, you know, it's less stability, but higher performance, better fuel consumption, better economics, better utilization for your aircraft. And here we say that whenever you are flying and you're trying to drift down, we talk about the takeoff. Whenever you are drifting down, you're moving the opposite way. You are drifting down. Okay, I wanted to ask a very important question here, but I will leave it to later to discussion. If you're drifting down, shall you drift down with the constant Mach number or a constant speed? I will just leave this question to the discussion because this is a little bit more complicated, and people of the flight operations will relate. If I'm going down, shall I go down with constant speed or constant Mach based on the aircraft performance? Okay, and again, if you are moving down, just pay attention. If you're moving down and your aircraft speed is increasing, that means that you're going with a higher rate and you're getting into the obstacle. Just pay attention to that. Okay, yeah. So eventually, if I want to keep the performance measures of my aircraft, you need to follow one of these three trends: either a speed schedule for maximum range, speed schedule for minimum drag, or speed schedule for minimum fuel flow. We will be talking about that in the detailed course for aircraft systems and performance. But actually, right now, it will be very, very complicated to combine all of these curves, okay? Like, you will get dizzy. So, yeah. So, basically, what we say is we have different speed profiles that we need to choose for the aircraft. And this will better utilize the aircraft and keep its market value. And just at the end, we need to emphasize that the engine derated, we have 3 types of engine duration. Manufacturer derated, that comes from the manufacturer. Assume temperature, you assume higher temperature to get less thrust, or takeoff derated. And all of these things, if they are installed on the aircraft on board, it increases the market value of the aircraft, because this will not save you fuel. This will save you depreciation of the aircraft, of the engine. This will save you deterioration of the engine, basically. It will not save you fuel, but it will save you the deterioration of the engine. And eventually, the last slide here, we're having an upcoming, like, basically, I did this session as an informative session. Basically, we are here saying that the people coming from the flight schools, they need this conversion between the flight schools and the commercial airlines. And so we prepared a specific course for them. Later on, we will send you the organizing entity, because like there are like some like different organizing entities for this course. So they will send you emails about the details of the course. But basically, where we'll be talking about the aircraft system significance, the ecosystem, and the cost structure very, very quickly. The fleet performance measures, how I perform the consider the performance measures of the fleet. The commercial aircraft aerodynamics, part of the glance that I talked about. Takeoff performance, fuel management for aircraft operation performance, flight safety compliance and competence, aircraft engine combination for system description and performance. Thank you very, very much. Did anyone understand anything from what we said today? Thank you. You can open your mics and please start your comments. Thank you very much, guys. So any comments? Did anybody understand anything from what I said?
باشمهندس حسام سامعني؟ First of all, yeah, thank you very much for your time, for the great presentation. Yeah, I have been working in aircraft performance for like 12 years, basically doing all the technicalities of all the topics you mentioned today. But it was the first time, yeah, for me to look into that from the commercial point of view. So now it's really interesting to know that, and to know how much these performance topics can affect the aircraft valuation. So it was, yeah, really interesting for me. Thank you very much. I just have a quick question to.
Yes, of course.
Just to clarify for me and for everyone, when I cannot remember the slide number, but when you mentioned the group 2 specific systems, were you referring to, for example, the let's say the chemical oxygen system duration, like 12 versus 22, something like that? That's what you meant, that it can affect the aircraft value?
Yes.
Or like or the fire suppression system in the cargo, something like that as well?
Yes, exactly. Fire suppression system, and they are not only the, like, I'm opening the slide again here if you can see it. They are not only the 2, it's just an example. They are not only the 2 systems, but my point is they are the systems that are time related. They affect the aircract value actually, because, and they are depending on the EDTO approval certification. You know, like, for example, I know, for example, the number in Boeing 737 NG, we have 2 bottles, 2 fire suppression bottles, and the aircraft is certified to fly EDTO, to fly 180 minutes extended range. Okay, and the 2 bottles for the fire suppression of the cargo can be working up to 192 minutes. So this is what I mean. You install more equipment to keep your aircraft in the extended range, not only the extended range, in the extended operation, to keep a better value for your aircraft. You know, this is group 2, basically. This is group 2. The systems that are significantly affecting the performance and aircraft value for the extended operations or and the extended operations, like just you need to pay attention that the extended operations means better economics. You know, like we showed on the graph. So
yeah,
so that means that better performance and better aircraft value. Yeah.
Yeah, I think that answers the question. It's even written. Yeah, I didn't see it because it's in small size. But yeah, thanks a lot. It's clear now. Yeah. Again, thank you very much. It was really interesting for me. Thanks.
Thank you.
Have a good day.
Thank you. Any other questions, guys? I'm looking at your answers. Yeah. Constantinos is saying like, actually not bankers. I know, like, not bankers. Yeah, I agree with you. Yeah. 4-inch got green dot. Yeah, the green dot is the best leftover drag. That's right. CG usually better for fuel efficiency. That's very correct. Airplane one is more stable. Yeah. Okay. Perfect. Any other questions, guys? Does anyone has any questions? That's it. Okay. So thank you very, very much for your time. I enjoyed the session and hopefully you also enjoyed it. Have a lovely day and see you in the next session, inshallah. Thank you. Bye-bye.